Hello, welcome. Hopefully everyone can see and hear me okay. I think everything properly. Hello, welcome to today's A-level revision. This session is going to be on the rate equation, which is a year 13. Most is done in year 13. Please feel free to say hi in the chat if you are here. It'd be lovely to know who's here. And welcome back if you're an old hat at these and you've seen these before. Welcome if this is the first time you've come to a session. It's lovely to have you here. If you haven't already, please have a go at downloading today's slides. The link should be in the description so that you can download them. It's a good idea to download them because it means you can keep hold of them for as long as you like. And then you can use the slides later for revision, or you can use them now to scribble all over them and save a copy for revision later, whatever you want to do. It's also a good idea to have the notes in front of you because it gives you the opportunity to back and just double check on the spec what it is that's being expected of you, etc. So yeah, please do download the slides for your use. They are for your use. But hello, hi Shargo, hello, welcome, nice to have you here. Feel free whenever we're doing these or whenever I'm doing these web classes, feel free to ask any questions you have in the chat. I'll do my best to answer them as we go. Hello, Harshit, as well. Nice to have you here. Then also feel free to answer each other's questions as well. If somebody asks a question that you think you know the answer to, then by all means, please have a go answering it, and then I will do my best to address any misconceptions or recognize when there's been a correct answer given. So we can all do that. We'll get started in a second. We'll just give it another minute in case anybody else is going to appear late. Yes, is it okay to ask if it's AS or A2 chemistry? So it's one of the topics which is sometimes done in AS chemistry because it links really nicely with the AS topic, but technically this is A2 level content. So the stuff we're going to be looking at here is actually found in the later part of the A levels. So it's in the A level, the whole A2 content. However, if your school or college or wherever you're learning does the linear 2-year course, you may have learned about this in year 12. How do we prepare for an exam in under 2 months? So the best thing for you nowadays is to have a go at exam questions. That is the thing that that research shows is the best. So there's no point in doing exam questions if you have absolutely no idea about a topic. But what you can do is do exam questions with a revision guide next to you or with your notes next to you and have a go at answering a question, because the biggest barrier for all students when doing exams is the questions. It's working out what are they asking me, what area of the topic is this questioning me on, what sort of answer are they looking for, how much detail do I need to go into. So doing exam questions and then marking them, obviously, please don't just do an exam question and leave it. Do an exam question and then mark it and use the mark scheme to check, or did I say that keyword? Did I use that key phrase? Have I done the calculation correctly? Etc. And when you do that, when you mark your answers, make sure you understand why. Why have they given that answer? Is it because they've asked for a definition and I didn't give a definition, but they have, so that's why they're looking for that answer? Or is it you haven't quite understood the process of math, so why have they used that number? Where have they got that number from? Just make sure you understand why they've given that answer. That would be my best tip for the next 2 months. Revision questions, revision questions, revision questions. Hello, Samara. Lovely to have you here as well. Oh, that was Zahid. Thank you very much. Welcome. How often are there web classes? We do these Sunday sessions, Sunday revision sessions every Sunday, and we rotate between maths, physics, chemistry, and biology. But on the Stanford Revised website, there are weekly web classes in all of those 4 topics, all of those 4 subjects, sorry. So there's a chemistry, physics, maths, and biology class every week on the website. Okay, I think we should think about getting started because the first thing we're going to look at, if my screen will let me move on. Hello. There we go. Oh, sorry, no, it's not the first thing. First of all, I'm going to say a little bit about me. So my name's Alyssa. I am the lead, I shouldn't say GCSE, I'm just the lead chemistry teacher at that provides. I got a PGCE in chemistry from Oxford University, but it's actually a PGCE in science, but chemistry is my specialism. And I've been teaching A-level chemistry for the last 9 years. I've been teaching science for the last 9 years, but chemistry is my specialism. It's my favorite. Okay. So just a super quick, I'll come to your question in a second, Denny, but just a super quick note. I'll say more about it at the end of this web class. So if you're interested, please, if you're watching this pre-recorded, then please feel free to skip to the end to find out more information. But I will cover this in a little bit more detail at the end of the web class. But if you're interested, Snap Provise are running A-level exam crash courses in the Easter holidays in biology, chemistry, physics, and maths. They are 2-day courses. So day 1 is year 12 content or A-S content. Day 2 is year 13 content or A2 content. You can come to either or both for any subjects, so biology, chemistry, physics, and maths. If you want to do it in person, it's going to be at the, and apologies, I don't know how to pronounce this, the Wall Enterprise Hub in London. Feel free to have a quick Google about that. So if you want to do that in person, you can come to that one, or we will be live streaming it, and you can purchase access to the live stream as well if you are interested. We do our first session of the day is on exam technique. Then we look at and we try to cover the trickier topics from AS and A2 sciences and maths. We provide a seminar booklet which you can take away with you, which has questions, notes, answers, etc. in it. And we also have a tutor messenger system, which means you can have access to somebody who will answer as many questions as you have during those sessions. So please feel free to investigate those. There's more information on the Snap Provide website as well. Okay. Right. Let's just address those couple of questions that we have got. So Denny, you've asked, how often should I do revisions and for how long should I sleep if I need to achieve higher grades in A-level? Little and often. Revision, again, it's proven revision should be little and often. So there's no point in doing 6 hours on a Saturday, 6 hours on a Sunday, and then nothing during the week. What you should be trying to do is doing, I would say minimum half an hour subject a day if you can, because half an hour is kind of the minimum time you would need to do some proper revision, be that an exam question or learning some definitions or whatever it is that you need to be doing at that point. So little and often is 100% the best way to go, rather than doing all of your revision on one day, which is why your teachers will keep telling you cramming is not useful. It can work, but it doesn't work anywhere near as good enough as little and often. So get out your revision timetable and plan small sessions, but regularly. I'd also recommend coming back to topics as well. So repeat topics every couple of weeks to allow your brain to forget it and re-remember it. That helps to really strengthen your memory pathways, makes it easier to recall things, which will make it easier in your exams. Would we recommend doing old spec exam questions if you're in year 12 to avoid using up past papers? Yes and no. If you're in year 12 and you've got time to kill, definitely, I would say it is worth it. The only thing I would do, and I'd do it now, especially if you're in year 12, is get comfortable with looking through your specification. So go through your specification of the subjects you've already covered, because we're in February now. Hopefully you've covered a few topics. Go through your specification on those topics that you've covered and check you understand how much detail you're expected to know, where you're supposed to get information from, how you're supposed to know the information. Are you supposed to be able to recall it? So does it say you need to know something, or does it say you need to understand something? If you have to understand something, you need to be able to explain it. So you could be given application of knowledge questions. If it just says you need to know something or define something, it's just recall. So yes, you absolutely can use old spec exam questions, and I do with my students all the time. But if you do, just get confident and comfortable with your specification, your new specification, because it will tell you what you do and don't need to know. So if something comes up, you think, oh, I I don't think I need to know that. Check in your spec, see if it's in there. If it is, you do need to know it. If it's not, you don't need to know it. Right, we'll come to some more of those questions, I think, later on, if that's okay, because it is 6:10 and I need to get on with actually doing this content. So we'll come to some more of those questions later on if we have time. So for this session, we are going to look at the rate equation and the rate constant. We're going to understand differences in orders of reactions and what that means. And we're going to look at determining the rate equation using experimental data from initial rates in a table. We're not going to look at units of rate equations, and we're not going to look at graphs in this session. We do cover those, but in a different web class. So speaking of specifications, so those of you who are asking about specifications, this is the part of the AQA specification that we're going to be covering in this session. So feel free to have a quick read through, check that you're comfortable with what they're asking, etc. So notice, for example, that it says students should be able to use concentration time graphs. That's telling us that there's not a recall, it's a use. So it's application questions you're going to be asked there. If you're EdXL, it's these spec points that you're going to be covering, or that we're going to be covering, sorry. And if you're OCR, it is these spec points. Again, double check, it says explanation and use of these terms. So you need to be able to explain them and use them in an explanation. If it says you have to, where's another one? For point F, it says determination of the rate constant. So you're going to need to find the rate constant, etc. Okay, so I'm just going to turn my screen over, which sometimes means my camera turns itself off, but I will be back in a second if it does that. Oh. Aha, it didn't. It always does that. Whenever I pre-warn, it never happens. And when I don't pre-warn, it does. Right, so let's have a look at the rate equation then. So, rates of reaction. Oh, I haven't done, no, it skipped ahead, didn't it? We didn't do what do we already know. Sorry. So this is from GCSE actually, technically, but also a little bit of A-level, AS level. What is the rate of something? So with these kind of web classes, it is, and with any kind of revision, it is best if you interact. You will get more out of it if you don't just sit and passively try to take stuff in. So have a go, have a guess, type it in the chat if you're feeling confident, or if you'd like some reassurance, or if you would like me to have a go at looking at what answer you would give, please feel free to pop it in the chat and we can have a look. But what is a rate? How do we calculate rate? What is the rate of something? Anybody know? Anybody want to have a guess? Pop it in the chat. I'll try and give you a short amount of time to have a go at answering things, but obviously we're going to need to move forward fairly swiftly in order to get through all our content. What is the rate of something? You'll have to forgive me drinking as well. I don't want to lose my voice. What is the rate of something? How do you calculate or determine the rate of something? Nice. Well done, Samara. Change in concentration over time. It's just a change in something, which if we're talking about rates of reactions, we're looking at change in concentration. I'm going to put conc because I'm being lazy in an exam. If you were writing the word, you'd write concentration. The change in concentration of reactants or products, either one would work, divided by the change in time. So over a change in time. Very nice. Lovely, fabulous. What does that symbol mean? We see square brackets quite a lot in science, and actually in different places they mean different things. What do they mean if I'm saying square brackets around something, a species, a compound or a substance? What does that mean? Yeah, nice. Well done, Eman. That's good. Concentration of. So it's concentration of whatever is in the bracket. So in this case, A is in the brackets, square brackets, so it means concentration of. Hopefully that's not new for anybody. If it is, see if you can commit that to memory because we use it quite often in chemistry. So it's useful to get that in your head. Okay, part 1 of our web class is on the rate equation. Let's introduce it. So let's imagine we have species A and B, these things, whatever they are, doesn't matter what they are at the moment, but things, A and B, species A and B, go to make C and D. We might write a rate equation that looks something like, this is a lowercase italics K, concentration of A times the concentration of B. That's an example of a rate equation. What does the lowercase, and that's, sorry, there is a typo there. Should be lowercase italics K, is what? What is it? What is that K? And what does it mean? Why have we included it in the rate equation? You meet it in a couple of times at A-level chemistry. This is one of them. What does it mean? What is that thing? What do we call it? And what does it mean? What is that? Very nice, Eman. Very good. It is the rate constant. And what is the rate constant? Why is that a useful thing? What does it show? What's it representing? It is the constant. Very good, Shargo. Very nice. It's the rate constant. What does it mean? What's it showing? It shows, if you look at the rate equation above, what's it showing? What is that K constant showing? It's showing the numerical relationship between the rate of a reaction and the concentration of the reactants. So in this case, A and, actually no, I'm going to put that, and the concentration of the reactants, whatever they might be. In this case, they are A and B. Yeah, sure. That's a really nice way of putting it. Yeah, that there's going to be a specific magnitude, a specific size of change in the rate of the reaction when we vary the concentration of the reactants. Okay, lovely. So, how are we applying this? What is this? Orders of reactions, they are a way of showing, yes, it is, sorry, it is directly proportional to concentration. Actually, yes, indeed. It's the ratio of the rate to the concentrations. Very nice, Denny, as well. Good. So the rate equation suggests a directly proportional relationship, as you guys have just said, by a factor of 1 between the rate and the concentration of the reactants. If we look, this rate equation shows that A, if I were to, for example, times A by 2, so I were to increase the concentration of A by 2, because there is a directly proportional relationship, the rate would also increase by 2. Hopefully you can see that using my equation. If A was, let's say, let's use easy numbers, if A was 3 moles per decimeter cubed, and then I change it to 6, so I've doubled it, the rate is directly proportional. Because of this equation, rate is equal to K, which is a constant, times the concentration of A times the concentration of B. If everything else stays the same and I double A, well, then the rate has to double. So let's just put those into words. If the concentration of A is doubled, then the rate is doubled. Or if I were to triple the concentration of B, then the rate would triple. Is anybody not happy with that? Because we've got A, just a concentration of A to the power of technically 1, concentration of A, it means there is a directly proportional relationship. This we call order of 1, or Oh, sorry, guys. I don't actually know what happened there. It was telling me that it had to run a test or something. Um, I'm back. Sorry, it was. Geez. Hopefully, please let me know if I'm back again. It told me, sorry, my laptop just told me that Microsoft had to run a test, and I don't know what that was, so I don't know why it did that. Let me just check that I'm all back again. I can't see. Where's my screen gone? Let's just stop. Right, I think I'm back again. Am I back? I can't see. It says it can't connect to the chat, which is not fun. Let me try that again. Sorry, team. How can anybody see? Oh, wait, is it not sharing? Is that why? Is it not sharing the right thing? Oh, what has happened here? Right, I'm going to stop sharing that because it obviously doesn't like that. Let's try that again. Let's try that. Right, that looks a bit better, I think. My screen thinks it's right. How are we doing? Is everyone all right, guys? Are we back? Yes, I'm hoping. Okay, phew. Right, thank you very much. Well done, guys. Sorry. Right, let's start again. Well, we won't start again. We'll pick up where we left off. So we said that. So you said weren't sure. Let's do that again. Let's go through first order again. So if something is first order, order one, it means there is a direct proportionality. So if we look at this rate equation up here on the top left. Oh, I can't rub those out. Never mind. We look at that rate equation. Picture it, think of it like an algebraic equation. If you had x equals, no, let's call it r. R equals k, concentration of A, so that's a number A, and concentration of B, that's another number or algebraic value B. If I times A by 2, so I have 2A, because there is a direct relationship, I must have 2R as well. Think algebraic expressions. If I double something on one side, I'm going to double the other side of the expression as well, because they are directly proportional, they're equal, and therefore equivalent to each other. So if I double something on the right-hand side, the number on the left-hand side is going to also double, because that B value stays the same and so does K. So that is what's called a first order reaction. If that happens, that is first order. So let's just put that in here. So rate is directly proportional to the concentration of A. And the reason we call it first order is because it's directly proportional to the concentration of that species to the power 1, which is itself. If you know your laws of indices, anything to the power 1 is itself. Okay? No, good question. What would that be? Would that be double 2? No. I would be running an experiment where I would choose to double the concentration of A, but I would choose to keep B the same. So in my first experiment, maybe I use 1 mole per decimeter cubed of A and 1 mole per decimeter cubed of B. And then in my second experiment, and then I'd measure the rate. And then in my second experiment, I'd choose 2 moles per decimeter cubed of A, but only 1 mole per decimeter cubed of B. So I've doubled the concentration of A, and I would notice that the rate has also doubled. Okay, so that is first order. That means if we, for example, times the concentration of A by 5, what do we think happens to the rate? If it is first order, it's directly proportional. Rate will also times by 5 to the power 1, because it's first order, so that is 5. So if the concentration of A is doubled, the rate would double. If the concentration of A is tripled, the rate would triple, if it's first order. It gets a little bit more complicated, though, when we start thinking about things being second order or third order. If something is second order, for example, rate is equal to K times the concentration of, let's say, C to the power 2. That means it's second order because it's got that second order 2. And we'll put D in there as well, why not? Then that means it is second order with respect to C. And what that means is if we have the relationship between rate and the concentration of that species is a squared relationship. So if I take the concentration of C here in my middle section here, my middle expression, and I times the concentration of C by 3, the effect it will have on the rate is 3 squared. So rate is then times 3 squared bigger, which is times 9. And again, look at that numerical relationship. It's because you've got this little squared value in there. If I were to times that by 3, if I were to have 3C, a concentration of 3 times what I used to have, then that 3 has got to be squared because it's got a squared relationship. That is the effect that it has on the rate. So second order means the relationship is proportional to the concentration squared. And just for completeness, you don't have to know this, but I think it does help to recognize it. Funnily enough, if we have third order, that would mean rate is proportional to the concentration of, let's say, E. So rate is equal to K times, this is a different species now, E cubed. So the rate is going to be proportional to the concentration of that species cubed. So again, to look at an example, if we take E and we times it by 5, let's say, we times the concentration of E by 5 in a second experiment, then the rate is times by 5 cubed. Because of this cubed relationship, it's third order, 3 third cubed, which means actually the rate would increase by 125 times. Oops, this should be cubed then. What this is doing is this is telling us how the concentration of individual species, individual reactants, the relationship they have with the rate. If something is first order, which lots of the times reactants are just first order, which means as you increase the concentration of a reactant, the rate increases proportionally. So you double the concentration of A, it doubles the concentration of rate. We all know about rate in terms of the higher the concentration, the faster the rate of reaction. So this is a numerical way of determining that. Okay. We'll come back once we've applied it to some exam questions, you might be a little bit clearer. So I'm just going to move forwards and then we'll come back and check our understanding in a minute. So we also, just talking of orders, yes, the square, yes, square of and cube of, yes, sorry, yes it is, yeah. My brain thought you had written root then, but yes, no, you're right, square of and cube of, yes, exactly. Okay, so we also just need to be aware of an overall order. So if we look at this example rate equation, we can determine that the order of reaction with respect to HCl is 2. second order. Again, that means every time we do anything to the concentration of HCl, we have to squared do that thing to the rate, or that's the effect it will have. So if I were to double the concentration of HCl, then it would double squared, so 4 times bigger, the rate. It would increase the rate by 4 times as much. So HCl is second order. This ethanol is first order because, you know, lazy scientists, we're not going to write down to the power 1 because we know that anything to the power 1 is itself. So I'm not going to write to the power 1, but we have to recognize that there is a 1 there. That means the overall order is 2 plus 1, which is third. The overall order of the whole reaction is third. Each individual species has its own individual order, but the overall order is third, or order 3. And if we were to get an educated guess, when the concentration of a reactant has no effect, that's supposed to be on the rate of the reaction, it's said to be what? When the concentration of a reactant has no effect on the rate of reaction, it's said to be what? Well done, Gabby. Lovely. 0 or 0th or 0th order. Very nice. You can say any of those. Lovely. What we mean by that is that if we had, what letter was I can't remember what I was on, F now, I think. So if the concentration of F is to the power 0, 0th order, anything to the power 0, think of your indices rules, anything to the power 0 is equal to 1. Let's just write that in. Anything to the power 0 is equal to 1. So if we look at the rate equation above, if I were to add that in, I could put F to the power 0 into my rate equation. So I'm showing the relationship between the rate of this reaction and HCl and ethanol and F. But F to the power 0 is just 1. So actually, I could, if I would prefer, like the lazy scientist that I am, cross that out and just write times 1 instead, because I'm timesing all of these together because they're next to one another. That means timesed by. So I'd just be timesing by 1. But why would I write times by 1 if I'm being lazy? Which is why we don't see anything to the power 0 in the rate equation, because why would we write it in if we didn't need to? Anything times by 1 is itself, so we can just omit it, we can get rid of it from the rate equation. So there may be reactants that are part of a reaction, but that have no effect on the rate. And therefore we won't see them in the rate equation because we're lazy and we don't include them. Okay. Now, there's a lot of information there, especially if this is the first time you've met them. So you might not be feeling quite so confident at the moment. That's absolutely fine. So just take a second to think about how confident you are feeling and whether or not you think this is nice and straightforward. And that was okay, but I might want to just double check my knowledge. Or if you're super confused at the moment, it's totally okay to be any of those 3, or even somewhere in between. But what we're going to do is we're going to have a go at applying this. And once we've applied it, hopefully we'll be feeling a little bit more confident. Okay? So let's look at doing some calculations. Once we put it into context, often people find it a little easier to understand. I'm also very aware of the time. I want to make sure we have time to go through this, and if we can, some exam questions, but this does tend to take a little bit longer, so if we don't have time for exam questions, apologies, we will give it a go. So this is a version of an exam question. It's not an exact copy of an exam question, but it's us trying to apply that stuff we've just learned about. So the following initial rate data was obtained for the following reaction. So for those of you that aren't quite as confident about this, I'm just going to explain the context here nice and quickly. Here we have a reaction. It's actually the one that we were looking at a little earlier. HCl plus ethanol goes to make water and chloroethane. We have added together our HCl and our ethanol in varying amounts of concentration. So trial 1, experiment 1, we had HCl at 0.5 moles per decimeter cubed and ethanol at 3.3 moles per decimeter cubed. And we measured the initial rate. So that's the fastest rate of the reaction, the initial rate, the rate at time equals 0, t equals 0. The initial rate, we measured that rate. And the rate for that first trial was 1.3 times 10 to the minus 3 moles per minute. We then repeated our experiment. We did trial number 2. In trial number 2, we kept the concentration of HCl the same as it was the first time, but we doubled ethanol, the concentration of ethanol. We then measured the initial rate. The initial rate was 2.6 times 10 to the minus 3. We then repeated the experiment a third time. We did trial number 3. In trial number 3, we took 1 mole per decimeter cubed of HCl and 6.6 moles of ethanol, and we measured the rate, and we got 1.04 times 10 to the minus 2. We can now use that data to determine the rate equation for this reaction. To begin with, we need to determine the order of reaction with respect to each of our 2 reactants. So how do we do that? Feel free, if anybody wants to, if you feel confident, jump ahead and see if you can come up with a rate equation. If you're not feeling confident, that's absolutely fine. We're going to have a look at it together. So how do we approach these questions? We approach these questions by comparing trials, comparing experiments. I'm going to start by comparing experiments 1 and 2. For the most part, in an exam question, they will lead you through it. So start with 1 and 2, then do 2 and 3, then do 3 and 4, or whatever, however many you need to do. Here we've only got 3 trials, so that's fine. Let's start by comparing trial 1 and 2. Trial 1 and 2. What has happened? What have we done? Well, when we had trial 1 and 2, we kept the concentration of HCl the same. So any effect that, or anything that has happened to the rate cannot be from HCl, because we've kept the HCl the same. So if the rate has changed, which I can see it has, it cannot be due to HCl. What have I done to ethanol? I've gone from 3.3 moles per decimeter cubed to 6.6 moles per decimeter cubed. That means I've doubled the concentration of ethanol. What effect has that therefore had on the rate? What has happened to the rate? It's gone from 1.3 times 10 to the minus 3 to 2.6 times 10 to the minus 3. That has also doubled. So for trial 1 and 2, it has doubled too. Good. What did we say if there's a direct proportionality? What order is that? If I double one and the other one doubles, there's a direct proportionality. So what order is that? Concentration of ethanol has doubled. Rate has doubled. So it is directly proportional. Very nice, Gabby. Well done, Shargo, as well. It is directly proportional, which is first order with respect to ethanol. So the reaction is first order with respect to ethanol, or ethanol is first order, you can say as well. Okay, lovely. So we've started to write our rate equation. That's good. We've worked out the order with respect to ethanol. What about HCl? Well done, Afnan, as well. What about HCl? Now I'm going to change colour just so we can see our workings a little bit easier. Let's compare trial 2 and trial 3. What's happened to HCl? I don't know if I said HCl ethanol then. I meant HCl. What's happened to HCl between trial 1 and trial 2? Oh, it's doubled. Good. We've doubled HCl, and look how handy. We've kept the concentration of ethanol the same between trial 1 and trial 2. That means, again, any effect on the rate of reaction will only be due to the HCl. That makes it nice and easy for us. What effect has it had? Well, what is the relationship between 2.6 times 10 to the minus 3 and 1.04 times 10 to the minus 2? That's actually 4 times bigger. First order means directly proportional. Yes, exactly. So by doubling HCl, my HCl is increased by 2 times, so I've doubled it. My initial rate is increased by 4 times. So this isn't now a directly proportional relationship. This is a squared relationship. Lovely, well done, Gabby. So it must be second order. Let's just second order this one because it's squared times bigger. Let's just look at them in a bit more detail. Trial 2 and 3. Concentration of HCl has doubled, but the rate has times by 4. And if we think about how does that relate to times by 2, that's 2 squared. Squared is what tells me it's second order. Second order. 2 to the power 2 times bigger. On the first one, it was 2 to the power 1 times bigger. So that means it's first order. For the first one, because it's 2 to the power 2 times bigger, that means it is second order. So it is proportional to the concentration squared. Proportional to the concentration of our species squared, which means it is second order with respect to HCl. They are our only two what are they called? Reactants. So yes, exactly. If it's cubed, it means third order. Yeah, exactly right. If the relationship is something cubed, bigger, it means third order. Exactly. So second order respects to HCl, sorry, to the concentration of HCl. And therefore, we can now answer the question. The question we were asked was to determine the rate equation. So we've determined the orders of reaction for our two reactants. Now we can write it into our rate equation. Rate equations are rate equals. Always how we start our rate equation. Rate equals. We have to put in our rate constant K. That's always included in a rate equation. And then we put our concentrations of our reactants to the power of their order. So it doesn't matter which way around you do it. I'm going to do HCl first, just because it's written on the left in the question. Doesn't matter, because it's a times relationship. You can put them in any order, can't you? And then it is ethanol. So that was HCl to the power 2, because it's second order. And then ethanol to the power 1, because it's first order. But I'm not going to write the 1 in because I'm lazy. So let's have a quick look. How do you know which reactant to do with respect to for the trials? Good question. So Harshith, to begin with, as I mentioned earlier, they like to, not always, but most of the time, they will write things in order in the question to help you along. So I would always look at doing trial 1 and trial 2 first. You should be able to see, so for example, if we look at trial 1 and trial 2, we've kept the concentration of HCl the same, and then we've changed the concentration of ethanol. So I know that between trial 1 and trial 2, I must be looking at how ethanol affects the initial rate, because that's the only thing I've changed. If for some reason they haven't given it to you nice and neatly like that, find 2 trials that you can compare where only one thing changes. If you can do that, then you know, again, that any effect that anything that's happened to the rate must be due to that one thing that has changed. Think about all of our scientific experiments and stuff. We always like to only change one thing. If you change one thing, you know that whatever results you get is because of that one thing that you changed. Yeah? Awesome. Does it sometimes go over third order? Is there a limit? Not a silly question at all. You absolutely can have fourth order, fifth order, sixth order, etc. But at A level, you're only likely to be asked questions on zeroth, first, and second. We include third order because they might ask for a little bit of might be like an extension-y type question, kind of the higher AA star level question, because it's application of knowledge, because the theory is the same. It's identical, it's just third order, so it's a cubed relationship. But if you look back to the specification, they only talk about zeroth, first, and second order. So supposed to be 0th order. It might be confusing. I've got 3 fingers up, but 0th, 1st, and 2nd order. 3rd order is there. It happens. So does 4th and 5th, but we're unlikely to be asked. Good question. We've got a couple of minutes. We're probably not going to have time to do an exam question, but let's have a go at this second question, which is a little bit harder. Okay, we'll see if we can get that done before our time runs out. And unfortunately, we won't be able to do the exam questions, but what I'll do is I'll give you the answers in a minute, and then you can have a go yourself and check that you get the same answers as me. Okay, so let's try. This is a trickier experiment, and they like to be tricky, okay? If you haven't quite got the slightly easier question that we did earlier, I know it's not easy, it's never easy, but it's easier, then please don't worry too much if you don't get these. I would just recommend you have a go at a lot of the easier questions. And once you get confident with those, then try some of these harder questions. The principle is identical. It's all the same stuff. It's just that there's a little added layer. So we'll have a go in a second. Mobile, we said at the beginning of this session that rate equations is technically year 2, but if you're doing the 2-year course, sometimes schools like to do it a little bit earlier. So you may have already covered it if you're in year 1 and you've done kinetics. They sometimes do them together, but technically it's year 2 or A2. Okay, so let's try this one. Again, the principle is identical. It's exactly the same. So we should all be able to have a go at it. We just might get stuck towards the end. Let's compare trials 1 and trial 2. We're determining the rate equation, so we need to find out the orders of reaction with respect to each one of our reactants. And this time we've got 3 reactants. That's what first level of why it's a bit harder. We've got 3 things to work out. So let's compare trial 1 and 2. Oh, look, isn't that kind? Our Al2O3 concentration has been kept the same between trial 1 and trial 2. Lovely. So has our concentration of water. Great. That means the only thing that will be having an effect on the rate will be the concentration of sodium hydroxide. So what have we done? How has that changed between our first experiment and our second experiment? It has doubled. It is twice as big. Yeah, nice one. Well done, Gabby. Fabulous. What's that done to the rate? Now what's happened to the rate then? Good, Shargo. How do we know? Because what's happened to the rate? The rate, is it double? 3 points, so the relationship between 3.7 times 10 to the minus 3 and 1.48 times 10 to the minus 2 is actually times 4. It's 4 times bigger, which is 2 squared. Because it's 2 squared, that means it's second order. Let's write that out. Trial 1, no, trial, I was supposed to say. Trial 1 and 2. I've got weird ands, by the way, guys, so sorry if that's confusing at all. Trial 1 and trial 2, the concentration of sodium hydroxide, square bracket sodium hydroxide, concentration of sodium hydroxide has doubled. The rate is times by 4. How does that relate to doubling? How does that relate to times 2? 4 is 2 squared. 4 is 2 squared. Because it's 2 squared, that little squared tells us that it is second order. So it's not the number 2, it's not the change that we make to the concentration, it's the effect that that change has on the rate that's important. So the squared, the 2 for the second order, comes from the fact that it is a squared relationship. So therefore, it is second order with respect to sodium hydroxide, NaOH. Okay. Yes, good. 2 to the power 2, it's 4 times the original. Very nice. So Tafara, it is 4. We doubled our concentration of sodium hydroxide. What effect did that have on the rate? It times it by 4. I'm interested in how that 4 relates to the doubling, the 2, the times 2. The times 2 is there, and it has been squared to get 4. So it's a squared relationship, which means it's second order, the 2 squared second. Let's try another one. I'm going to change color again to try and make it easier. funnily enough, let's do 2 and 3. If I do that, I have doubled the concentration of Al2O3. I've kept the concentration of sodium hydroxide the same, and I've kept the concentration of water the same. Brilliant. That makes it fairly simple, or simpler. That means that any effect that's happened to the rate, anything that's happened to the rate, is purely because of the Al2O3. And what has happened? What's the difference between the rate in trial 2 and the rate in trial 3? Yeah, lovely. It's also doubled, which means it's directly proportional. So it's 2 to the power 1 times bigger, which is first order, 2 to the power 1, first order. It is directly proportional. So trial 2 and 3, the Al2O3 concentration has been doubled. The rate has been doubled, i.e. times 2 to the power 1, because 2 to the power 1 is itself. That little 1 tells us that it's first order, or the fact that it's a directly proportional relationship. Very nice, well done, Shargo and Tafara. Directly proportional relationship means it's first order. So it is first order with respect to our Al2O3. Nice. Okay, this, I happen to know, is where it's going to get a little bit tricky. I'm going to write in. No, let me just highlight that little 1 for a second. I'm going to write in purple. Okay, now I'm going to compare trial 3 and trial 4. Well done, Denny. Apologies, we disappeared for a second as well, so hopefully you're able to catch up okay. Let's compare trial 3 and 4. Again, feel free to jump ahead if you feel confident. But what's happened? Well, between trial 3 and 4, we have doubled the concentration of Al2O3. We've kept the concentration of sodium hydroxide the same. And oh, look, we've doubled the concentration of water as well. So that means whatever effect we have on the rate has actually been influenced by the change of 2 things. Now that's okay, we can cope with that. What we need to do is bear in mind we're trying to work out what effect water has had, changing the concentration of water has had on the rate, but we have also changed our concentration of Al2O3. So that means we might find, or we should find, that there's actually 2 things that have influenced the rate. So what does this mean? How do we deal with this? Oh, that looks promising, Gabby. We'll just double check. We'll just double check, because this is where it can get a little bit confusing. Let's go back to our first column here. We know we have doubled the concentration of Al2O3. What effect will that have had on the rate? If it was just the Al2O3 that was changed by doubling the concentration of aluminium oxide, we will have doubled the rate. Because we know from our previous trials 2 and 3, that it is first order with respect to Al2O3. That means if we double the concentration of Al2O3, we double the rate. So the rate itself has actually times by 4. If you double check using your calculator, you can see that that is times by 4. So it's 4 times bigger. Times 2 of that times 4 is from doubling Al2O3. So let's write that out. It should be very close to 4, but it's probably just a rounding that's happened. So apologies if it's not exactly 4. It should be close to 4. So Al2O3 has been times by 2. So that doubles the rate. That means there's also a times 2 that must be due to the water, because 2 times 2 times 2 times 2, sorry, is times 4. So times 2 of that times 4 comes from Al2R3, the other times 2 must come from water. The concentration of H2O has also been doubled, and that has further doubled the rate. Again, if the concentration of water has doubled and the rate has doubled, that means it must be first order with respect to water. So it is first order with respect to the concentration of water. Think about what the number would have been otherwise. I'll write it up here. If we look at what the rate would have been if it was just down to the Al2O3, it would have doubled because we know that it's first order with respect to aluminium oxide. So it would have doubled and it would have been 0.0592 or 5.92 times 10 to the minus 2 if it was just down to the Al2O3. To get from 0.592 to 1.18 times 10 to the minus 1, that is doubling. That's where we know that water, when we double water, we double the rate. I'm going to have to finish that because we are very close to running out of time. So, to finish off, rate is therefore equal to K times Al2O3. I'm just going to write it in order of how they've been given. To the power 1. I'm not going to write in the power 1 because I'm lazy. NaOH to the power, to the power 2, and then water to the power 1. Again, I'm not going to write water. It's hard, that's why these are trickier. You have to look at how these two things have influenced the rate. Right, apologies, we're going to have to move swiftly on. I'm just going to write the answer in here for those of you who want to go at this in your own time. The rate is equal to K, concentration of that thing to the power 1, concentration of that thing to the power 1. That's if you're interested in doing that question. And this one, rate is equal to K to the power of A times the power of X. Oh, sorry, to the power of 1 even, times the concentration of X. Okay, feel free to have a go at those. We've had a look now at rate equation and rate constant, differences in orders of reactions, first, second, third, etc., and determining the rate equation using experimental data. If you have any questions, pop them in the chat, but I'm just going to give you a quick bit of information about our exam courses. If you're interested, please feel free to pop onto the website, Snaprovider's website, to find more information. But basically, we spend the first session going through exam technique. We look at breaking down questions, how to work out what answers are expected from you. We look at the command words and how to interpret those. And we look at the range of question types that will come up in your exams. And then we look at a step-by-step approach to writing full mark answers. We then spend the rest of the day looking at the trickier topics from AS and A2, Year 12 and Year 13. We revise concepts from the most challenging areas of the course and use exam technique skills from the morning to answer a range of difficult questions together. There are seminar booklets which we hand out to you when you arrive if you're going to come in person, or that we send over to you if you are doing it online. You can complete them throughout the day. You can add in your own notes and answer the questions in there, and then you have answers that you can use to then mark the questions that you've done. It's an incredible take-home resource, and it's jam-packed with extras like mock exams and end-of-topic tests. And we also offer this thing called Tutor Messenger. So it's an additional support tutors to answer your questions. They're available on your phone if you want to use it on your phone, and you can ask as many questions as you like just to double check how it applies to your specification, or what was the key word that we used, etc. So if you're interested, you can come in person at the, again, I don't know how to pronounce it, Wall Enterprise Hub in London, or you can live stream via Zoom. There are two options there. And when, so these are the dates for physics, maths, chemistry, and biology revision courses. So chemistry, year 12 is on the 8th of April, year 13 is on the 9th of April. So if you're interested and you want a little bit more detail, please feel free to head over onto the Snaprovider's website. it is here, saprivice.co.uk/seminars, and that will give you more information about timings, prices, etc., etc. Okay, right. Sorry, I did have a couple of questions. I'll see if I can speed answer them. Why was the rate of water 1 you had to square 2 to get the 4? Oh, so Gabby, for that one, A-levels is hard. I know they are. I know, and chemistry, in my opinion, is one of the hardest. So, oh, I'm gonna sneeze in a second. Apologies. Why was the rate of water 1? So the order was water for water was 1 because we doubled the concentration. Let's go back here super quickly. We don't have much time, but I'm gonna just give it one last go. Because we'd doubled the concentration of Al2O3, that will have doubled the rate. So if we'd kept the concentration of water the same, the rate would have doubled. So times 2 of that times 4, the double, one double of that times 4 was because of we changed the Al2O3. So the rest of that, as in another times 2 to get it to times 4, must have been because of water. And we know we doubled water, so therefore the other part of the times 4, so times by 4 is like saying times 2 times 2, isn't it? Double, double. So double, times 2 times 2 gets you to times 4. So one of those doubles comes from doubling Al2O3, the other one must come from water. So it's double water to double the rate. That's a first order relationship, directly proportional. Yeah, it's hard. It's really hard to do these like multiple step ones, which is why we put it in as a trickier experiment. Okay, right. I'm going to have to head off now, I think. So apologies for that, but hopefully you're now feeling a little bit more confident about rate equations and rate constants. I would highly recommend you do some exam questions just to practice and to have the answers in front of you and double check your answers and check you understand them. And I wish you all the best of luck and hope to see you in a future web class. So we'll have a look at our timetable and we will find you, hopefully see you in a future web class. Oops. On YouTube or on the website. Lovely. You are awesome. Well done, team. And I will see you soon. Bye.